Hello children, once again welcome back to chemistry class. Today we are going to learn a new chapter, that is classification of elements, the periodic classification of elements. Okay, in the lower classes you might have learned the topic matter. So the matter is made up of three important components. What are they? They are elements, compounds and mixtures. So the elements and compounds are the pure substances. Okay. Now let us go into the classification of elements. Okay. When you go to the library or when you go to the hypermarket, how the things are arranged? They have arranged in a very order and systematic. Why they have arranged in a order and systematic? Because it should be easy to locate the things for the outsiders, right? Yes, here we are going to classify the elements such a way. So based on what? So based on what criteria the elements are being classified?
Based on the alphabetic order? Or the examples like based on the color? No. The scientists were continuously thinking that based on which we can identify. Yes, the classification is based on the properties of the elements. Let's example like the physical state like solid, liquid or gas. No. Or based on the density.
Children, do you know how many elements are present? Yes, in the earth crust you can see that there are 118 elements. You will be surprisingly knowing that this huge amount. So out of this 118 elements, the 98 elements are the naturally occurring elements. And the rest of the elements are man-made. Okay. So children, the scientists were continuously made an attempt to classify the elements in a order. How we have arranged the things in our rack. The scientists were continuously tried their best. So finally, a scientist came with his first classification. The name of the scientist is Dobereiner. The first classification is the Dobereiner's classification. Dobereiner is a German scientist. Okay, he tried to classify the elements into a set of three. A set of three is known as triads. Hence, it is known as Dobereiner's triads. He had taken a first set, that is lithium, sodium and potassium. The mass of lithium is equal to 7 atomic mass unit and the mass of potassium is equal to 39. And what is the mass of sodium? That is the Dobereiner's law. Dobereiner's law states that the mass of the first element and the mass of the third element. When you calculate the mean mass, that will be the mass of the middle element. Okay, here you can see 7 plus 39 divided by 2, which is equal to 46 by 2. You will get 23. The mass of sodium is equal to 23. Okay, in the first triad means 3 elements. Okay, this is possible for the first triads. Let's go for the next examples of some triads. And let us find out, is it possible to all the elements that are being discovered on that time. During that period, you can see that only 20 elements, 25 elements are being classified, discovered. Okay, so is it possible to all the elements? Let's go for that.
Look at the triads here. These are the possible triads. The average of the mass of the middle of the element is possible here. So when we talk about the other, like nitrogen, potassium, arsenic as a triad, so when you calculate the middle mass, the average mass, which is not at all matching. Okay, so the Dobereiner's triad is not possible. So children, you can finalize that only he could identify the 3 triads. To summarize the Dobereiner's triads, classification is important to study elements. Dobereiner's first attempt to arrange elements, and the next, atomic mass is the basis of his classification. and Dobrenius triads contain three elements with similar properties. Atomic mass of middle element is the average of the first two. The limitation is only 3 triads out of 25 elements.
Okay, so what you observed, there are some limitations of Dobrenius triad. Dobrenius triad is possible only 3 set of elements. The rest of the elements, it is not possible. So, how you will arrange the rest of the elements? So, in order to overcome the Dobrenius limitations, there is a new scientist whose name is Newlands. The name of the scientist is Newlands. So, the classification is known as Newlands Octaves. Newlands Octaves. Children,
have you ever played a piano? Yes, you can see the 8 musical notes. The set of 8 musical notes are known as octaves. So the first note sa resembles the last note. Okay. So every 8th element has properties similar to the first element. Okay, in the Newlands octaves, so after lithium, the 8th sodium resembles same. Like same way, after boron, the 8th aluminium also resembles the same property. Okay, from there the law originates. The Newlands law octave says that every 8th element in the order of increasing atomic mass has properties similar to the first element. Okay, coming to the Newlands octaves, one of the achievement is he can include every Dobrenius triads.
okay, was the Newlands octaves perfect? No. What Newlands said? Newlands said that every element should repeat. The 8th element should repeat the first element's property. Okay, but is it possible to every cases? No. So you can see that cobalt and nickel having different atomic mass have listed in the same slot. Let's look into that.
Out of 56 elements, the law was possible only up to calcium. So the law was failure after calcium. Look at here children. The chlorine and bromine is entirely different from cobalt and nickel. Since cobalt and nickel is a metal, but he included it in the same slot. But iron is similar to cobalt and nickel, and iron is placed far away in the table. The same problem is faced by the cerium and lanthanum also.
The time the Newland discovered the elements, so that time there is a discovery of noble gases. So what are noble gases? Noble gases known as inert gases. They are helium, neon, argon, krypton, xenon and radon. Where he will fit these noble gases. This noble gases is entirely showing different properties compared to the rest of the elements which is present in the Newlands table. Okay, he was unable to fit these elements in the Newlands octave. Okay, let us see what he did.
The position of hydrogen and fluorine were in the same slot, but the entry of the noble gas helium displaces them. Go to the summary of Newlands octaves. Newland observed that every 8th element had properties similar to the first when they were arranged in increasing order of atomic mass. Coming to the second point, he coined the term law of octaves to represent this 8th element similarity. The first limitation of the law of octaves was that it was valid only till calcium. The second limitation arose when Newland adjusted multiple elements with different atomic masses inside one slot. Third limitation occurred when cobalt and nickel in the same slot came in the same group as chlorine and bromine. Finally, the discovery of noble gases entirely shifted the position of other elements.
In order to overcome the limitations of Dobrenius and Newland, there is a new scientist. Okay, that his name is Mendeleev. In the next class, let's move into the Mendeleev's periodic table. Okay? Till then, we'll see you in the next class. Take care.